This video is for the quadratic function Frayer model. So a quadratic function is a second degree polynomial function that can be described in standard form by 0 equals ax squared plus bx plus c, where a cannot equal 0. So this is standard form of a quadratic equation. Something like x squared plus 2x plus 3. That's a quadratic function. So some facts. Quadratic equations make a parabola when you graph them. And this is a U shape. So when graphed on the coordinate plane, so with a quadratic equation or a quadratic function, the sum of the roots, which is the solutions, is negative b over a. So if you add the two solutions, the two zeros, the roots, it's the same thing as taking the coefficient for b and the coefficient for a, dividing them and changing the sign. The product, so when you multiply the roots, product of the roots is c over a. Okay, so examples. So in standard form, we might see f of x equals 2x squared plus 4x minus 6. Now we can take that same function and we can write it in factored form. And it would be f of x equals 2 x plus 3 times x minus 1. Same function, just written in a different form. And then we've got vertex form. And vertex form is handy when we're graphing quadratics. So f of x equals 2 x plus 1 squared minus 8. And so your vertex are these 2 points, your x and your y. So some non-examples. F of x equals 4x plus 6. So remember our definition said the a value cannot equal 0. If a equals 0, it cancels out that variable term of x squared. So that is not a quadratic. F of x equals 2x cubed plus x squared minus 2x plus 8. This one is not a second degree polynomial. So that was also part of our definition, that it had to be a second degree polynomial. When we have a cubed term, that's when it becomes not a second degree polynomial. So the squared term makes it second degree. Anything above that cancels that out.